My guest today is John Woods. John is the CTO at the Nillion Association, which is, I guess, described as humanity's first blind computer. Essentially, what does that mean? It means it's a secure computation network that decentralizes trust for high-value data. But we'll learn all about this today, of course. Welcome to the show, John.
Thank you so much, Andy. Great to be here.
Great to have you here, John. Let's do what we do at the beginning of the show. It would be super cool if you could introduce yourself. Would love to hear some of your personal and professional backstory. What have you been doing in the lead up to joining the team at Nillion?
Yeah, cool. So, hi, everyone. I'm John Woods. I'm fighting out of Dublin, Ireland. Yeah, I've been involved in tech and I guess for the last decade or so, distributed systems engineering across a number of projects in the Web3 space. I guess notably, worked at Consensus on Ethereum. I worked at IOHK, which is the company behind Cardano, which is one of the biggest by value networks in the world. And then just before I joined Nillion, I worked at Algorand, which is also a very notable layer 1 cryptocurrency. And so, yeah, now I have joined Nillion, which is a little bit different, right? Because it's not a layer 1 blockchain like Cardano or Algorand. In fact, although it has a token, this cryptographic token, this cryptocurrency that powers the utility of this blind computer or this kind of private federated, compute and storage technology, it itself is not the blockchain, right? It itself is really focusing on trying to be an analog of a computer, but one where the computation and the storage is always private.
Yeah, well, give us a little bit of context then. So you mentioned some of the Algorand and Cardano, some layer ones that you worked on previously, John. What was it about Nillion then that was attractive to you, and you thought, well, that's my next mission, if you like?
Yeah, sure. And so, look, on these, just, going back to Cardano and Algorand, like what I did there was usually tech leadership type position, but my focus was really software engineering, architecture, applied cryptography. And that is, enhancing the networks to provide a better product experience for the users, or indeed maybe a better level of security or developer experience. But if you look at what those products do, I call them products. I know they're not like the iPhone or something, but if you look at what Cardano provides to the world, or what Algorand provides to the world, or even say Ethereum provides to the world, what these things try to do is provide a platform on which you can run software. Now we call it smart contracts on these blockchains sometimes, or discrete programs or whatever, but ultimately they're trying to be an operating system on which you can run little applications. And so the question always becomes, why would you want to run software on Algorand rather than run it on Microsoft Windows, on Amazon, on Azure? And the answer there is because these decentralized layer ones provide an extra assurance that you don't get on those other platforms. And it's the assurance of the veracity of the execution of the application. So these smart contracts are kind of checked by consensus globally, and there's thousands of computers making sure that the code you've written is executed line by line exactly as you intended, without having a centralized authority. So that's what they do. And so I've always thought that was cool. I like the idea that it enabled use cases like peer-to-peer payments, peer-to-peer applications that don't require trust, so you don't have to trust the guy you're trading with, and that can be as simple as selling your concert ticket without having to worry that you're being scammed. But what most of those networks don't provide, in fact, essentially any of the major layer 1 blockchains, although they assure the veracity or the truthfulness of the execution of the apps that run on top of them, they don't do so with privacy. Now, privacy is something that actually got me into the crypto space. I was very I was very interested in cryptography generally, and the types of things it allows you to do. So in my general work, I cared about encryption. I cared about privacy by design. I cared about strong security, as one has to when they're working in traditional software engineering contexts. And then, through the love of learning cryptography and understanding how that stuff works and how I can apply it in my career, I learned about technologies like Monero, which are blockchains that have privacy. But things like Monero try to do private payments. things like Algorand, where they're more complex, or Ethereum, where it's more complex, and you have smart contracts, it's very difficult to achieve privacy there. And so I've always wanted to work on a project that was directly focused on enhancing privacy generally. And there's not a lot of, like I said, there's not a lot of projects in the space that do that. I think Monero does it very well, but it's quite niche. It's focused on payments, like Zcash, same kind of thing. And so Nillion was the first time a major project came along that was focused on bringing private compute, like general purpose private compute, to the world, and indeed to finish the computer analog, or maybe analogy, private storage as well. And so that's quite compelling to me. And I think we live, speaking now, I guess more generally, I think we live in a time where privacy is more important than ever. And I see, as I look around the world without bringing politics into it, I see many countries where privacy is completely violated, or we see the introduction of digital IDs and social credits and other bits and pieces like that are not good. Or even, for example, within the European Union, where I live, there's a lot of agenda pushed around introspection of your private messages, whether that's on WhatsApp or Signal or iMessage or other platforms that you use, to scan them for wrongdoing. And it's never sat well with me. It always felt quite Orwellian to do those kind of things. And I think if you can work on technologies that foster more adoption of privacy enhancing technologies, we call them PETs, but yeah, essentially privacy enhancing tech, I think that's a good thing for the world. And I think it's generally important. And I think a lot of people grew up, myself included, with the internet, and people who are in their 30s and 40s now who maybe got used to the idea that, you do tell Google everything about yourself when you use Google Maps or where you're going or whatever. But I don't think that they're healthy things in the long term for people.
Yeah, that's very well said, John. Look, I think, one of the easiest ways for people to understand what you guys are doing with Nillion, of course, is just to maybe, just from a very high level overview, explain what the kind of the different use cases are versus a layer one blockchain.
Yeah, sure, absolutely. So yeah, as I mentioned, layer ones ensure the veracity of code. We call those codes smart contracts, or little apps that run on the layer ones. Nillion is different. So Nillion, at its core, if you were to boil it down completely, what you'd be left with is a number of Lego bricks. I call it Lego bricks. Maybe that's not cool anymore, but like primitives or basic building blocks that we call blind modules, or privacy enhancing technology modules. And so what these things are discrete pieces of software that allow you to do either computation, which is cryptographically provably private during its execution, storage, which is cryptographically, from an information theory point of view, shared in a way that is that without collusion cannot be recovered, or indeed, something that's quite hot right now, of course, is AI. This idea of inference. People are running models locally in their homes on their Macs, and people are using, of course, ChatGPT and Sonnet, Claude, and all the other bits and pieces that are out there. One of the core primitives that we have, one of these Lego bricks or building blocks, is we call it Nil AI, but it's a module that basically runs AI models in a private way. And of course, the first thing that came to my mind when I heard that they were able to do what is essentially technically called large language model inference, or running a ChatGPT privately, is, how fast is it? How good is it? Is it, what's the overhead on trying to achieve this cryptographic attestation of privacy? And it turns out it's only about a 10% slowdown. So you're still at like 93% of the speed of a normal large language model when you're using it. But I think it's interesting. We live in a time when people are, if you look at the X, or Twitter, now X, AI companions that people are using, sometimes people are using them in a romantic or sexualized way. Or if you look maybe at even ChatGPT, people are uploading their work contracts or their medical records for assessment, with that platform. And so it's again, it's one of these things where people are kind of not realizing maybe how much they're divulging to private enterprise, and it's a good thing to have the ability to run an AI model privately. But yeah, if you take Nillion, you boil it down, what do you get? The magic, the secret sauce It's a bunch of primitives. We call them blind modules. They do things like private compute, private AI, private storage. There's other bits, private search. And we construct them, we kind of stack them up, and we make what is the blind computer, right? So you take compute, you take storage, you take AI inference, you take private GPU, and you bring it together, and you basically get this kind of private computer. We've called it the blind computer. and one other thing to mention to the viewers, although Nillion has a token, and the token powers the execution within these blind computers that exist around the world, the blind computers are not a decentralized network in the sense that the blind computer in country A or city A does not talk directly to the blind computer in city B or city C. They are what we call federated instances. So they're distributed, a bit like email servers. They exist all over the world. They're able to coordinate between each other, but it's not like an Algorand or an Ethereum where every block in the blockchain is seen by everyone. These are kind of discrete private instances of these computers. And you, as an end user, can pick which one you want, and then you can go and use the token to interact with it, assuming that it's got the collection of blind modules that are interesting for you.
Yeah, thank you, John. And look, I mean, you're exactly right. It's quite interesting, the kind of, I guess, the timeline that we're living in at the moment. You know, you referenced the Grok virtual companions, which are capable of engaging in, quite erotic fantasy behavior, as you've alluded to. OpenAI, of course, Sam Altman, I think he said that ChatGPT, they're going to release the guardrails a little bit on chat and make it be able to do similar things for, I guess, age-gated users, but, and you use the example of people uploading, work contracts and things like that. And I believe I'm not sure how accurate this is, but, OpenAI are also investigating ways to, whether it's viable for them to run ads, and the kind of ad targeting that would be achievable on something like ChatGPT is quite scary. So I guess in that context, it is good for people to have alternatives. One of the challenges with this, John, of course, and it's the same challenge that I guess privacy tokens like Monero or Zcash have faced in the past, is getting that kind of user buy-in or user adoption, or the ability for just the average person to understand exactly what is going on and how much do they care.
Sure. I think this is a really important thing, because you're right. It's not just a tech, right? You can build this blind computer, blind modules, blah, blah, blah. You can stack them together. It can be all very cool. And then it's like, hey, do your parents use it? Does your brother use it? Do your friends use it? I think deeply about this. I think it's very much a social thing. And there's not a ton of examples of where privacy has reached escape velocity, but I have some. Even though I wasn't prepped for this particular question, I have some. If you think about, I think maybe it's the classic example, but if you think of HTTPS, right? And when I say that, I mean, we assume now when we're on a website, our bank, even this video call with you, everything from my home to your studio is encrypted essentially. And we see the little padlock icon, and what people may not realize is that years ago, most websites, the information sending between your computer and the website was totally unencrypted, and so it could be literally sniffed or intercepted by even people who are not that technically literate or technically gifted. And so now, with the proliferation of technologies like Let's Encrypt, which is basically I believe in like a nonprofit that really pushed the idea of encrypted websites, or encrypted HTTP traffic, we've essentially reached a place where secure communication with websites globally, whether that's your bank or your local church website, is essentially always encrypted. And in fact, modern computers like your Mac or your iPhone or your Android phone, they typically won't even visit a website that's not encrypted anymore, or doesn't have an encrypted connection. And so Signal maybe is another example. Most of my friends took a long time to get them to a place where they were using that technology, where they were willing to move to a second app when they were already using WhatsApp or iMessage. But we got there, and I think we've reached a kind of an inflection point, I feel. And this is only my personal commentary, looking socially at this point, but there's kind of, well, one, I think there's a surge of excitement around privacy in the crypto space. And I think, discussing it with colleagues, that if you try to pinpoint why did that happen, like recently, you know, we've seen Zcash rise very much in value. We've seen Monero's like in the top 20 cryptocurrencies, depending on where you look. Privacy has been talked about by the Ethereum Foundation and Ethereum, and privacy is a very hot narrative at the moment. Now, why is that? Maybe it's a resurgence of a little bit of the cypherpunk DNA of crypto. You know, it originally started as a kind of a two fingers to the banks, and maybe we lost some of that over the years, and maybe privacy is being used as a vehicle to kind of bring cypherpunk back. But also, as I alluded to earlier, I feel like more than ever, we live in a time where people are a little bit more conscious about what they put online. I mean, we've seen arrests in many what we would have considered civilized countries for what at some points was very little put online. So people are thinking, you know, when I post something, I've got to be careful. People are thinking, you know, if I'm not careful with my bits as I spray them around the internet, this might come back to haunt me. And I think the current generation are a bit more aware of it, and so I think we're going to see a social drive towards privacy adoption. Maybe not to the same degree as AI, but certainly to in a more substantive way than I've ever seen before. And I've been working in kind of security engineering for a long time in one way or another.
Yeah, I very much agree. That's very well articulated, John. You know, and speaking of, you know, Zcash and Monero and so on, a lot of privacy systems do lean heavily on you know, different formations of zero knowledge, I suppose. So where does Nillion diverge or fit in on that kind of trajectory?
Yeah, great. It's a great question. Thank you, Andy. You know, at the end of the day, I was kind of thinking about this as because there's like the privacy wars, right? Like people are like, oh, you know, TEs, they're shit. And then it's like FHE, it's way too slow. And you know, MPC, you know, what about my collusion? And so, you know, you have different projects that are, of course, trying to reach that escape velocity, get users, get attraction. And sometimes you see infighting between the various entities out there. Brave browser, could be Signal. You see infighting between these various privacy kind of projects, Web3 or otherwise. At Nillion, we've taken this stance that we're agnostic. We're agnostic to the underlying technology. You know, like Zcash as an example, very much is, I use ZKP to do private payments. And that's cool. But what we're doing at Nillion is saying, we use whatever collection or smorgasbord of privacy enhancing primitives we can use to stack them together in a way that we can deliver a meaningful production experience. And so maybe let me kind of dive into the tech and give a kind of a super quick blurb, like for the sake of a minute. When you look at fully homomorphic encryption, obviously a mouthful of a word, but it basically means, FHE basically means, people can do compute on data without knowing what the underlying data is. So once again, it's like, I can give my data to someone encrypted, they can compute on it, they can run some function on it, give it back to me, and they won't even know what the underlying data was. Very cool idea. ZKPs, they don't really mean privacy. What they typically do is allow you to compress information, or allow you, I guess, more directly, to prove something without revealing the underlying thing with which you're proving. And so that you know, a zero knowledge proof is really about saying, I can prove something related to this information or about this information, but I don't have to show you the information for you to believe it. And so that's a very interesting primitive as well. MPC, you take that and you think, well, what does that do? And it's essentially saying, let's all work together, maybe to calculate the average salary of everyone in this office space, but no one wants to actually tell you what their salary is. So MPC is a cool way to kind of collectively, without revealing each other's inputs, reach an aggregated computation. And then, of course, TEs, which we do use in order to achieve this 90% speed of LLM inference in a way that's cryptographically private. They're about creating a small, trusted enclave with which inside you have a cryptographic attestation of computation and cryptographic attestation of the privacy of the compute. Now, these are all cryptographic primitives, and many of them over the years have been weakened or attacked, as they should be, by the way, because research and academia enhance how great our technologies are. And so I welcome new novel cryptanalysis, which will only make our privacy stronger. But over the years, various technologies have been broken or weakened. And what we've decided to do at Nillion, as I mentioned, is really tried to select the best of breed across all these different things and stack them in a way, just like you're making a cocktail or a nice sauce, try to bring together the best of the ingredients in a way that provides the best experience right now. But just to be clear, if there was a zero knowledge primitive or a zero knowledge technology in a year's time that allowed us to do AI inference at breakneck speed with absolute privacy, we would drop TEEs and we'd drop whatever else we're using now, right? We're about moving to whatever is proven and production ready, if that makes sense.
Yeah, got it. Thank you, John. What would you say are the biggest design trade-offs then in terms of, going permissionless for something as sensitive as private compute? There's nothing more sensitive.
Right, totally. So, and this kind of follows, I guess, maybe the release of our Nillion 2.0 roadmap. And so Nillion has been a non-decentralized technology. And so what I mean by that is there are many instances of Nillion technology, the Nillion blind computer, but we don't, and we have this token that powers it, right? But this token lives on a blockchain, but the blockchain is not part of the day-to-day compute and storage of the network, right? We don't use blockchain within the Nillion core tech stack. And so we're moving to a place where we're going to bring the community, as most Web3 projects try to do, we're going to bring the community into the topology of the network. And that's into the DNA or structure of the network. And so we looked at many different ways we could do this. We could have the community run nodes, that is, provide storage, provide compute, and scale the network dramatically. Or another way we could do it is by having the community come in, a bit like a Bitcoin mining hash rate, and basically run little computers, like normal computers, Raspberry Pi, Mac Mini, Intel NUC, your Dell PC, run a normal computer, and have the community's computers check the cryptographic attestations that are put out there by the blind computer instances. So you've got these big blind computers, and they're saying, "Hey, I'm computing this AI thing privately," and they produce a mathematical proof of that. You have other computers out there that are storing gigabytes of data privately, and we want to test to make sure they've still got that data and they're still holding it privately. So we're going to have this kind of sea of community checkers watch and verify the attestations and correctness of the network. A little bit like Ethereum ensures the veracity of the execution of smart contracts. Our Nillion attestation verification layer will make sure that the blind computer operators are behaving themselves. And so this is a wonderful kind of symbiotic relationship. You have a community that's ensuring the veracity of the network, and then you have entities who are able to run the blind computer at scale, delivering a world-class kind of private compute experience. And then just to answer your question more directly, because I don't want to be like a politician, with the way we've executed the technologies with staking, so you take the Nillion token and you're able to stake it to one of these checker layer guys, that keeps them well behaved because they'll lose money if they misbehave. And then similarly for the guys who are running the blind computer, right, the people who are running the actual compute, the actual storage, they too would get slashed or would lose money if they misbehaved. And so although it's permissionless, we've put in place cryptoeconomics to ensure that it's not in people's interest to misbehave, if that makes sense.
It does. All right. Well, look, John, as we start to finish up this part of the podcast for people listening, for developers especially, for people that want to get involved, take a closer look at Nillion, what is the best way for people to do exactly that?
Yeah, sure. So you can come to Nillion.com, where we have all of our developer documentation and indeed documentation about Nillion itself, and you can learn about the blind computer. But if you want to see what we're actually doing now, because a lot of blockchains, and again, we're not a blockchain, we are a Web3 project, they talk about what they're doing, but it's sometimes hard to kind of ascertain, hey, how much is actually running on this thing? And so we've just launched a new dashboard. It's available at dashboard.nillion.com. So that's dashboard.nillion.com. And if you head there, you will see, all of the projects that are currently live on Nillion. And critically, you will see what they're about, but also how they're leveraging Nillion. And so I think that's really important for people to understand exactly what's going on. And so, yeah, that's available right now at Nillion.com.
Nillion.com. Link is in the show notes, folks. All right, John, it is time to finish up the episode, and we do that, of course, by running you through the very famous crypto conversation hot take round. Are you up for it?
I am.
Just going to run some questions at you, John. I just want you to give me your kind of short, quick, snappy, hot take style answers, if you like.
You got it.
Let's see what you have to say. Question 1 for you, John, is very simply, where would you say that you sit on the Bitcoin maximalist to multi-chain opportunist spectrum?
I would say I'm definitely more of a multi-chain head. I think Bitcoin is very interesting. It's got a zettahash of compute. It started this thing, but I think it doesn't solve for all use cases.
Yep. What would you say then, John, is your firmest conviction crypto opinion?
I would say my firmest conviction is that crypto money without privacy is non-fungible and non-functional.
Yeah, I love it. I love it. All right, look, Bill Gates famously said that we tend to overestimate what we can achieve in 2 years and underestimate what we can accomplish in 10. So anything you like here, but, Nillion, what does it look like in 10 years' time?
Okay, well, in 2 years' time, it's decentralized, permissionless, with well-executed tokenomics, and it is running in its best form with the most varied availability of blind compute modules. In 10 years' time, I would like to think that it's adopted post-quantum technologies and has a thriving developer ecosystem. And I would like to think that it powers, or certainly is providing the infrastructure for critical production enterprise systems.
I like it. Sci-fi author William Gibson famously said, John, that the future is already here. It's just not evenly distributed. With that in mind, can you think of an example of the future being here right now, but most people aren't aware of it?
Oh, wow. That's a deep question. I think the future here right now, maybe the closest thing I've got off the top of my head is like the ability to run very large param local models on your computer at home. Like, so for example, with my parents and myself, I have 128 gigs of RAM in a MacBook. Now, it did cost me an extra $2,000 or whatever when I ordered it, so it wasn't cheap, and I won't be doing that very often. But I'm able to run GPT OSS 120 billion, so I can run a 120 billion parameter model on an airplane in my hotel room, or more critically, I can give it the most intimate or close facts about myself or my family or my children or whatever, and I don't have to worry that information is being sent to the cloud. And I think people don't realize the power of like local compute and what you can achieve with it in your home. And I think over the course of the next 20 years, we will see that Jarvis in the home, that kind of heavy compute cluster in the home, and people will stop providing, I think, so much information externally.
Yeah, makes sense. Brings us nicely to the final question, John, which is very simply, what is your favorite science fiction book, film, or TV show?
Oh, well, I'm going to have to go with Star Trek: The Next Generation. That was the one with Picard, right? The bald guy. And not just because I'm bald, but just love the vibes off that 5 p.m., in the 1990s. That's good shit.
Yep, that's classic Star Trek right there. Not vintage Star Trek, but classic Star Trek. It probably is vintage by now, but yeah, great selection.
That's the problem, isn't it? Time moves on.
It does. Thank you so much for coming and spending some time with us today, John. This was a lot of fun. Again, just close it out by again telling people where they can go to learn all about what you and the team are building at Nillion. Yeah,
thank you so much, Andy. So come to Nillion.com or dashboard.nillion.com to learn about what we're building. But I would ask folks, we are launching what we think is going to be a game changer in terms of compute infrastructure. We're bringing, Ethereum brought the world computer. We're bringing the encrypted computer to the world. And we think that this technology is going to empower not only small scale apps, but also enterprise and industrial scale apps. And so I would ask you, if you're interested in learning more, follow me on Twitter. And my handle sounded cool when I registered it, a decade ago. It's not that cool right now. At John Allen Woods, that's at JOHN, John, ALAN, Allen, and WOODS, Woods. At John Allen Woods. If you follow me on Twitter, feel free to reach out. You can actually, my DMs are open. You can ask me a question. If you want to follow up on something here or you want a pointer, just hit me up. I would love to talk to you. And we're trying to build a wonderful developer community and user community. So thank you so much, Andy. Appreciate it.
Awesome. Thank you so much, John. All the best and bye for now.
See ya.